Okay, next we're going to talk about polymorphism. And we saw that in our previous example, we could override a method in a derived class and use the type of reference to determine the call. Okay, so using a reference to the derived type will cause the correct method to be called based on the type of the object that the reference points to. So remember, we had our foo class. It had a print. Then we overrode print in the bar class, which extends foo. So down here in main, we create a foo reference f, and we point it to a foo object, and a bar reference b, and we point it to a bar object. And if we call f.print, as expected, we see inside foo, and when we say b.print, we see inside bar. Okay, so that's kind of, to me, expected behavior. Since the types of references are foo and bar, it makes sense that we should be calling the correct print method based on the type of the reference. Now, polymorphism allows the method to be called to be based on the object that the reference points to rather than on the reference's type. Okay, so let me show you how this differs here. Let's say instead of B being a bar reference, what if we made it a foo reference? So foo b is equal to new bar. Okay. Turns out we'll get the exact same output as we did before. Okay. So when we say b.print, even though b's type is of type foo, b really points to a bar object. And when you have a reference that points to a bar object and you call print, it's going to call the print method that belongs to the bar class, not the foo class. Even though b's type, the reference b's type is foo, since b points to a bar object, we're going to call the bar's print. Now this has a name. This is called dynamic binding. Even though the b reference is a foo type, the object that b points to is a bar, so bar's print method is going to be called. The compiler is okay with this, where before it might have had a problem with the calling pop hood. You might remember that example. The compiler is okay with this because we know for sure that a bar object does in fact have a print method. In the vehicle case, we couldn't be 100% sure when we were doing that downcast. We weren't 100% sure that every single object pointed to by a vehicle reference did indeed have a pop hood. So that's when the compiler issued the syntax error. But in this case, we are 100% sure that every single bar object will have its own implementation of print. Polymorphism only applies when using a reference to a base class. In this case, the base class was foo, and b's type, b is a pointer, b's type is foo. This is legal because bar is a foo. Right? The inheritance specifies that is a relationship. Polymorphism is used when a class is too generic to implement one or more methods. So if I ask you, well, how does a vehicle move? That's really a hard question to answer, right? Because a boat moves different from a car, and a car moves different from a space shuttle. A vehicle is not specific enough to answer that question. But there are still some things that are common to all vehicles, the odometer, for example, that we would still like to inherit from in a base class. Another thing that's common is that all these vehicles move. All vehicles share this trait, but each one does it slightly differently. So we want to be able to inherit the ability to move, but let the derived classes decide how each individual one is going to do it. If I had a boat, a car, and a space shuttle object that inherit from the vehicle class, each object can be sent the same message to move, but each object will react differently. Okay, so this idea of dynamic binding, it's the process of deferring the decision of which method to execute until runtime. So again, we have these pointers that could point to objects of different types. Dynamic binding says, let's wait till runtime to decide which actual method is going to be run. And it all depends on what the reference points to. It all depends on the object that the reference is pointing to. In the example above, if a vehicle reference points to a boat object and we call move, then the boat's move is going to be called. If we make the same vehicle reference point to a car object and then call move, well now, even though it's a vehicle reference and now it's pointing to a different object, it's going to call the car's move method. And again, this is dynamic binding. Static binding is when the compiler decides which method's going to be called at compile time. So not at runtime, but as the code is being compiled. By default in C++, C++ uses static binding. If you want this polymorphic behavior, you have to use some special syntax. But in Java, all methods are dynamically bound. We don't have to do anything special or use any special keywords. A class that declares the existence of a method but does not provide an implementation is called an abstract class. And a vehicle is a good example. A class can be marked as being abstract with the keyword abstract. Okay, so let me give an example here. We'll use our vehicle. Whoops. We want to mark this as an abstract class. So abstract is a keyword. All keywords are lowercase. Okay, so we said all vehicles have something in common. They have the odometer value. Okay, but then we said vehicles also have something in common. They all move. Okay, but at this level, vehicles are too generic to specify how a vehicle moves. Okay, but we know that all vehicles move, so they share that in common. Since I don't know how to implement move in the vehicle class because it's too generic, I would mark this move method as being abstract. Notice instead of giving a function body, which is normally what happens when I specify a method, I'm just going to put the semicolon to end the declaration of the abstract method. Now I'll probably also want to have getters and setters for the odometer. Okay, because that's some data that at this level we do know how to deal with. We can have private int get odometer that returns the odometer, and private void set odometer that sets the odometer value. Okay. Now we're going to have a class called car that extends vehicle. And this one is non-abstract. Okay, so this class will fill in the missing details about how to move. So we don't have to mark it as abstract. We'll say this one, though, does extend the vehicle class. Okay, so how does a car move? Well, it says vroom vroom. Okay. Let's have another class called space shuttle that extends vehicle. And again, it's going to override the abstract move method. Okay, but a space shuttle moves very differently than a car. Okay, and then let's create a driver here. So let's imagine we had this public static void main. Okay, so we have this vehicle reference v1, and we point it equal to a new car object. And again, this is totally fine. Car is a vehicle, so we can have a vehicle reference point to it. And we have vehicle v2 equal to a new space shuttle. Again, a space shuttle is a vehicle. We said a vehicle has this method called move that all derived classes inherit. The only difference was in the vehicle class, we left that move method empty. We couldn't implement that. We didn't know how to implement it in the vehicle class. Okay. But we said, well, the car class knows how to move, and the space shuttle knows how to move. It did slightly different things. Right. Okay, so when I say v1.move, of course what we're going to see is v1 points to a car, so we should see the vroom vroom. And v2 points to a space shuttle, so we should see 3, 2, 1 blast off. Again, polymorphism means look at the object that the reference is pointing to and call the correct method based on the object, not just the reference. Okay, so what's kind of surprising, I think, is we can do something like this. I'm going to swap v1 and v2. I'm going to make them point to the different objects. So right now, v1 points to a car. If I swap here, vehicle, let's call it temp, set it equal to v1. Now, temp points to this this car object. I could set v1 equal to v2. Now, this pointer is pointing to this one, and I could set v2 equal to temp. Okay, so maybe we could draw a picture here. We have v1 and v2. Okay, so v1 was pointing to a car. v2 is pointing to a space shuttle. Okay, what I just did here is I created temp, and I set it equal to v1. That means temp points to the same thing v1 points to. And then I said v1 is not going to point here anymore. It's going to point at whatever v2 points to. And then v2 is going to point to whatever temp points to. So v2 is not going to point here anymore. It points here. So v1 points to the space shuttle, v2 points to the car at this point. Now when I say v1.move, again, because of polymorphism, the decision about which method to call is not going to be based on the reference. It's going to be on what v1 points to, which right now is the space shuttle. And when I say v2.move, again, at runtime we'll decide, well, what is v2 pointing to right now? Well, v2 looks like it's pointing to a car. So when we call move, it's going to say vroom vroom. Okay. An abstract class can contain variables and methods that are not abstract. Okay, these are the common parts of a group of classes that can be shared. So all the odometer stuff, for example, in the vehicle class. Anything that's too generic to include in a class is abstract. So in the vehicle class, the move method, we can't answer the question, how does a vehicle move? It really depends. So that's too generic, and we make that method abstract. Anything that's not too generic to include in a class, of course, can be shared and inherited like we've been doing so far. So the odometer, the getter and setter for the odometer, those we'd want to push up the inheritance hierarchy and then have the car and the space shuttle and the unicycle absorb all of those for free. One thing about abstract classes, you cannot create an object from an abstract class, but you can create a reference. Let me show you here. Okay, so because we marked the vehicle class as being abstract, if I were to try to do something like this, this would cause a syntax error, okay? Because the vehicle object, since it doesn't know how to move, right? It's too generic. You know, if we were allowed to do this and we said v.move, you know, what would happen at that point? Right? We already decided at the vehicle level, we don't really know how a vehicle moves. It's dependent on the type of vehicle it is. So if we were allowed to create vehicles, we would then be allowed to call move, and it doesn't really make sense at this level to be able to do that. Okay, so we can't create actual vehicle objects. This is the part that's the problem. If a class is abstract, we can never instantiate it or create an instance of it. However, we can still use the vehicle reference. This is perfectly fine. Now, V is its type is vehicle. It has access to all the vehicle methods. And a car is a vehicle. A car inherits everything that is a vehicle, including the odometer and the ability to move. However, the car fills in the details about how it's going to move. Okay, so a class marked as being abstract must have at least one abstract method. And classes that inherit from abstract classes fill in the details by implementing the abstract methods. And that's exactly what our car class did. It provided its own move method. And when we say v.move, okay, because v is a vehicle and move is in the vehicle interface, V happens to point to a car. A car knows how to move itself. And at runtime, the correct move method will be called. Not the space shuttle move, not the unicycle move. The car move will be called because the vehicle reference V points to a car object.